Alright! In last video we have connected all the sensors and actuators required to run the Speeduino ECU on my Vitara with carbureted engine. If we succeeded on this conversion, we will then install this E10 Supercharger so we can build some boost. Now it's time to open TunerStudio and start to set all configurations and parameters on our ECU. Let's go there! All the information that you might need to work with Speeduino and TunerStudio configuration can be found here on Speeduino.com under Support Documentation, including information about the various versions of Speeduino boards. To start using our Speeduino ECU, the first thing that we need to do is to install the firmware. So we will click here on Installing Firmware and download the Speedy Loader. Run the X file and then select the latest firmware available and click Choose Port, so we can set the communication port between our PC and the Speeduino board. It is important to say that the board must be connected to the computer by USB cable. Click Refresh just in case and then Upload. This will start uploading the firmware to the Speeduino ECU. After the installation is complete, we may get the base tune file so we don't start the ECU configuration completely from scratch. Here we have a few options for various models, but as our car is not listed here, select generic base tuning. This will still require a full configuration, but at least we have some preload values, so save the base tune file in a known location. The next step is open TunerStudio and create a new project. Let's name it My Car YouTube. Then click on Detect Firmware and the Speeduino board should be listed. Wait until the search is finished, just in case, and then select your board and accept. Then click Next and choose our default units. I will change the temperature to Celsius and activate the hardware test option, which allows us to test the injectors and the ignition system without the car is running. You can also activate this option later. Then click Next and the TunerStudio will perform a connection test and you should receive a success message here. Then click Next and Finish and the gauge display will appear. Finally, before we start tuning, let's import the base tune file that we downloaded from Speedy Loader by clicking File, Load Tune, select your file and the base tune will be uploaded to the ECU. You can see that some configurations are already preloaded in the configurations options. You also get the warning Settings Change that require a power cycle to take effect. When you get this warning, the only thing you need to do is to unplug the USB cable from your computer and plug it in again. Finally, it is important to mention that all the TunerStudio configuration parameters are also explained in Speeduino.com under the tab Configuring TunerStudio. The first thing that we will set is the configurations that fit our car under Settings tab. In first line, we have the engine constants. Here, under Required Fuel, we will set our engine displacement. In our case, 1600 cc's with 4 cylinders. Then we need to set our configuration characteristics. The injector that I am using is a Bosch injector, and according to the information available on witchhunter.com, it has a flow of 450 cc per minute. And as we are using gasoline, we are aiming to an air-fuel ratio of 14.7, which is also known as stoichiometric ratio. You can find more information about this on this link. Then click OK and set the remaining options. We will leave the control algorithm using map information, and then as we only have one injector to 4 cylinders, we will set 4 squirts per cycle. Injector staging does not make sense for our configuration, so we leave it default. Set 4-stroke engine with 4 cylinders and throttle body injection with only one injector. The remaining options don't make sense for our configuration, so we will leave them default. Just make sure that the board layout is correct and then click Burn so the configurations are stored in ECU. Finally, to the change state effect, unplug the USB cable from your computer. You will see the offline message and then plug it again. In the injector characteristics, for now I use most common configuration, which are a maximum dirty cycle of 85% and an injector open time of 1 millisecond. And then we must pay very attention to what we are doing, the trigger setup. In our case, we use the camshaft gear wheel which has the 40 teeth, and we grinded one for reference. So I choose missing tooth pattern, apply it to cam speed. Our wheel has 40 teeth with one missing. Now in the trigger angle, we need to set the position of tooth number 1 in respect to the top dead center of cylinder number 1. The image is not perfectly centered, but when the camshaft is in this position, with this mark aligned with this mark on the cover, the piston number 4 is in top dead center. So if we put here an angle measurement tool, we have the tooth number 1 at around 180 plus more or less 30 degrees. We will use this value and fine tune it later with the stroboscopic light. Finally, our sensor outputs 0 when detecting the tooth, so the trigger edge is set to falling, and we set the trigger filter to the recommended value, which is mid. New power cycle, and we are good to go. To end this section, I open the IIT density and biofuel correction, but I maintain the default settings. The next step is to calibrate our sensors. As you can see in this screen, even if my throttle is completely off, the reading on the TPS sensor is that the throttle is at 4.5% open. This requires calibration. To do that, let's go to Tools and Calibrate TPS. The calibration process is quite simple. With the throttle completely closed, you click Get Current, and then again with the throttle wide open. Then click Accept, and the reading should be correct. Next, we calibrate the pressure sensor. As I use the map sensor recommended by the Speeduino, the option is listed here. If you use other than this, you will have to calibrate the pressure sensors as well using custom configuration. Then we calibrate the temperature sensors, the IAT and the CLT sensors. To do that, just go to Tools, Calibrate Temperature Sensors, and then select the CLT sensor. The CLT sensor resistance variation along the temperature is available on car manual, so I use the 3-point term generated and select the 3 points available in the most common operating range. Include these values extracted from the car manual and then set the BIOS resistor to 2490 ohms, which is an internal resistor of the Speeduino ECU, and click Write to Controller. Then change to IAT sensor and repeat the process. Note that the IAT sensor values are different from CLT. Finally, write to controller, and that's it. Next sensor to calibrate is the AFR sensor. I use the narrowband AFR sensor, so I selected narrowband and write to controller. And this concludes the sensor calibration. Now it's time to start adjusting our ECU tables: volumetric efficiency, ignition timing, and target AFR. I recorded this part of the process with the ECU offline, disconnected from the computer, so the recording would be easier. With TunerStudio you can do this, and when you connect the ECU to the computer, it will load all the changes that you made. Having said that, I first configured the VE table. Click on Tunning, VE table, and I use the VE table generator. Include the required data and then generate and apply VE table. Note that this table is not optimized for your car, but it should provide a good starting point. Also, the VE table generator is only available for the registered version of the TunerStudio, but if you don't have it, you can use this website, which is on the description, and can generate the table that you can import to TunerStudio. I will explain how in a bit. The TunerStudio don't have an ignition advanced table generator, but you can import a table. So to configure this table, I went to this website, which is also listed on the video description, included my engine data and generated this table. To ensure that the file header is correct, what I did to import this table to TunerStudio was first export the current table to a known location, then open it with Notepad editor, and finally copy-paste the data generated by the website to my file. Then save the file and imported it to TunerStudio. The process for the AFR table was similar. I exported a copy of the existing AFR table, then I went to this website, input my data, generated table, and then imported it to TunerStudio. After the table configuration, we need to set the ignition type. In my case, I used the wasted spark coil pack and I kept the 5 degrees advance while cranking. Then, and this is important, set the output trigger. Note that improper configuration might damage the coils. I set mine to going low and then click burn to save the configuration. Finally, you still have a few parameters that you need to configure, namely the accelerator enrichment, AFR control algorithm, and parameters regarding the cranking, priming, and idling. But to be honest, at the time that I did this filming, I didn't know exactly what they were, and I kept the default values. Now I know that these parameters must be tuned observing the car behavior and using small adjustments. Later, I tried to obtain the behavior that I desired. Either way, the default values on these parameters should not prevent your car to at least idle properly, so let's do it. Okay, so all the configurations were loaded to the ECU, TunerStudio was connected to save logs on the ECU parameters, and then I tried to start the car. Ignition on and nothing. The car is cranking, but it don't start. I don't have many videos on this part because, to be honest, I was a little bit scared. But in summary, what was happening was the following. When I tested the injector operation into the studio hardware testing mode, it worked perfectly. However, when the engine was cranking, the injector remained closed. I was able to start the car a few times by setting the injector in hardware testing mode, inject some gas into the throttle body, and then crank the engine. With the gas available in the throttle body, the car started, but it was very hard to keep it working without stalling. But even when I could keep it working by pushing the throttle on and off, I had a few backfires and a lot of black smoke coming out the exhaust. At this time, I started to mess with TunerStudio configuration, and using wrong configuration, I was able to set the car idling. The main changes that I made was to set injector characteristics to 200 cc per minute instead of 450 cc per minute, and this VE table. I don't have a lot of knowledge on this, but from what I could learn so far, this table is ludicrous. For example, in the idle zone there is a lot of vacuum created by the air restrictions, so the VE values should be rather small. This is not right for sure. And despite the fact the car idled, it was only idling very rich, and if I reduced the VE values, the car stalled. At the time I edited this video, I was able to solve all these problems and others, and I will explain the problems and the solutions in the next video, I promise. Currently, we are already able to do this. And this. Still need a little bit of tuning, but it works. Thanks for watching. Feel free to leave your comments and subscribe for upcoming videos.